Assalamu alaikum. In this series, Mr. Omar has guided you through some practice problems to cover all items included in the coverage issued by Emirate Schools Establishment, E.S.E. This is the last part. Have a fruitful time.
Welcome to the last part for this series. So, Assalamu alaikum wa rahmatullahi wa barakatuh. Now, for this question, I'll explain some idea. It will help you to solve such a questions easily for pendulum and sewing. A father pulls his son, whose mass is 25, and who is sitting on a sewing with ropes of length 3 meters backward until the ropes make an angle of 33.6 with respect to the vertical. He then releases his son from rest. What is the speed of the son at the bottom of the sewing motion? Now, this is the fixed point at which the pendulum or the sewing will be hung. This is the vertical line, and here is the sewing or pendulum. The length of it is L, and at equilibrium the pendulum will be here. Also, this length is L. This is the equilibrium or the bottom of the sewing motion. It is here at B, and here it is A. Now we need to find the height, this height, H. How much is H or HA? H is the height of the point A. HB, it is the final position. By definition, we will see the next term. Now, this distance, let it be y. Then h plus y equals the whole length of the pendulum. I need h it will be L minus y. What about y? If you know this angle theta, then cosine theta is the adjacent, which is y, over the hypotenuse, which is L. This is y and this is L. So y equals L cosine theta. Put it here, L minus L cosine theta. This is h. Now if you have two initial positions, angle theta initial and theta final, you can write h initial equal L minus L cosine theta initial, and h final L minus L cosine theta final. And if you need to find delta h, which is h final minus h initial, you will put easily L minus L cosine theta final minus L minus L cosine theta initial. Then L minus L cosine theta, distribute the minus L plus L cosine theta. We distribute the minus here and here. Now you can cancel L with minus L and rearrange your equation to find that delta H equals L cosine theta initial minus L cosine theta final, which is L times cosine theta initial minus cosine theta final. Why is this? Because I need to use the conservation of energy. delta K plus delta U equal external work. Delta K it is 1/2 m V final squared minus V initial squared plus delta Y, delta U is m G delta H equal external work is 0 for this question. Now you can multiply by 2 over m. You cancel 2 with 2 and one of them. Then V final squared minus V initial squared plus 2G delta H equals 0. Rearrange the equation. V final squared equals V initial squared plus 2G delta H with a minus sign. This is a minus sign. Then V final is the square root of that. V initial squared minus 2G delta H. V initial squared minus 2G delta H, it is L times cosine theta initial minus cosine theta final. That's it. So the thing I need you to remember it is this: how you find delta H. For our question, this is the vertical position, which is at the equilibrium, and this is the initial position. This is initial and this is final. This angle is theta initial, which is 33.6. Theta final, it is the angle between the swing and the vertical. This is the angle between the swing and the vertical. It is 0 because it's coincide in the vertical. So theta final equals 0. Now substitute here. Square root of V initial 0 minus 2, 9.8. The length of the rope is 3. Cosine theta initial theta x minus theta final, it is 0. And that's it. Use your calculator. That is 3.13 meter per second. And we took the square root, so plus or minus. For our question, according to our drawing, take the minus sign. Because the swing is going here to the left, passing through. Question. Force as a vector, R as a vector, and I need the work. A constant force F acts on an object of mass 8, causing a displacement of theta. What is the total work done by the force? The total work can come from dot product. Put the vector F 4.7 minus 3.79 2.09 dot the vector of R 25 3.69 minus 2.45. This is Fx, this is Fy, this is Fz, this is Rx, this is Ry, and that one is Rz. So the dot product, you will multiply x with x, y with y, and z with z. That's it. 4.79 multiplied by the x component of R, which is 4.25. Then add to it Fy dot Ry, So it is minus 3.79 multiplied by 3.69. Then add to them the last term, Fz times Rz plus 2.09 multiplied by minus 2.45. Do the calculation and get the answer. It's 1.2519 joule. If you approximate it, it's 1.25 joules. So we use the formula work equal Fxrx plus Yry plus Fzrz. For this question, there is an addition comes most of exams. Find the final velocity. If the object starts at rest. After you find W, you do that equal delta K. W equal delta K, which is 1/2 m V final squared minus V initial squared, 1/2. For our question, the mass is 18. V final is unknown, not from rest, and the work is 1.2519, and you will get the velocity easily. It is 0.373 meters per second. An object changes position due to a force as shown in the figure. Use the graph to determine how much work is done by the force while it decreasing. Where is the decreasing of the force? There is a trap. Beware. Some will tell me that the decreasing of the force is all the way to this, which is wrong. Because the decreasing of the force is from here only to the intersection with the horizontal. After that, there is an increasing in the opposite direction. So the decreasing of the force only from 2 to 5. From 2 to 5, here we have decreasing of forces. We need the work equals area under the graph. F versus R. What is the area? It is area of a triangle. Which is 1/2 base times height. 1/2. This is the base from 5 to 2. 5 minus 2. And the height is this one from 3 to 0. So the answer is 4.5 joules. Alhamdulillah, the last question. The graph shows the components F cosine theta of the net force that acts on a 2 kilogram block as it moves along that horizontal surface. Find the net work done on the block. The net work, again, it is area under the graph because we have a graph. I have here two areas. This one, I will name it as A1, and That one, the smaller one, I will name it as A2. Now A1, L times W. L from 1 to 5, so it is 5 minus 1. The height from 0 to 2, so it is 2 minus 0. This is the height from 0 to 2. This is the width from 1 to 5. Five minus 1 is 4 times 2, it is 8. Newton meter. Because the length force, it is N, and the width in meters. Now A2 equals the same L times W. L, it is from 5 to 7, so 7 minus 5, this one. W from 0 to minus 1, so minus 1 minus 0. So the answer here is minus 2 meter. So the network equals A1 plus A2. A1 is 8 plus A2 minus 2, so it is 6 joules. Find the final speed if it starts from rest at S equals 0. Here we need to find how to use kinetic energy work theorem. Delta K plus delta U equals, and the surface is horizontal, so delta U equals 0. Delta K, it is 1/2 m V final squared minus V initial squared, and the total external, it is given 6 joules. 1/2. The mass, I think it is 2. Yes, it is 2. V final, I need it. V initial from rest is 0. The work is 6. So V final is square root of 6. Plus or minus 2.45 meter per second. Have a good time. My best wishes. I hope you do the best every time. Assalamu alaikum wa rahmatullahi wa barakatuh.
I hope that this series has enriched you a lot. In the description box below, there are links to both a PDF document for answers and the other videos in this series. This is the end of the last part. Best wishes in your exam. Good luck. Salam.